This is a SolidWorks design of a drone for the Engineering Graphics class at Cape Fear Community College, instructed by Dr. Hans Chapman. This project was created and presented by Ross East, Josh Metley, and Quavion Hill. This is the model drone used for measurements that were taken in class. The exact details were not replicated in our design, however, this model served as a basic framework. Here we have our rough hand sketches of the main parts. We have our main body, including the motors, the landing gear, and the propellers.
This is the main chassis of our drone that makes up the main body. It consists of 4 arms that extend from the main body that each contain a motor mount, which is a cylindrical hole for the motor to slide into, allowing for the completion of the drone. It's also equipped with 4 smaller holes on the bottom of the drone that allow the landing gear to attach to the drone, giving the drone a safe and stable base to land on. This is the landing gear for our drone. As you can see, the bottom consists of a rudder type of base that will contact the ground, keeping the drone safe. As you can see, off of the rudder come 2 poles that is used to attach the landing gear to the drone. We only have one side on display here, but because the sides are identical, we can just use the same part twice to connect to the drone to give it an extremely steady base to land on. The last of the 4 parts that it took to complete this drone build are the moving components. This consists of the motor and the propeller. The motor clicks into the chassis of the drone, and then the propeller clicks onto the top of the motor, allowing the drone to fly.
Figure 5 shows the completed assembly of the drone. Creating this design required skillful use of lofts, splines, and fillets. The landing gear is attached to the base, and all 4 motors and propellers are working. This drawing document showcases the front, top, and isometric views, along with a detailed view of the propeller. The right view was left out as it provides no additional information. This is a vertical load simulation on a nylon propeller. The base is fixed and the load is placed along the edge of the propeller, resulting in a diving board-like deformation with the max stress being applied at the joint. Figure 10 showcases a propeller animation. And figure 11 showcases an exploded view of the assembly. In conclusion, we decided that planning ahead and brainstorming is essential. Ideas and designs must be coordinated between the group members. Objects with complex contours are difficult to model and simulate, and that one should consider exactly which tools will be needed in SolidWorks before deciding on a project. Our takeaways are that we improved our ability to plan, model, assemble, and animate in SolidWorks, and that understanding team dynamics is important for overall success.